which you are not allowed to design and certify anything until you are approved to do so. So that is Malaysian Civil Aviation Regulation 2016. Regulation 21 says that an organization may engage in any stage of design, manufacture or construction of any aeronautical product in Malaysia if organization holds certificate of approval issued by the CEO. So the new regulation, the amendment to this, the DG will be the CEO of CM. So by looking at the regulation 21.1, we have no option for you to design and certify a drone. You must be approved by the CEO. So what kind of approval? So you must get design organization approval, which already has been published in the by the CM, which is design organization approval, CM Part 21 Sub Part J, or the CM Directive 8401. So this is regulation for you, which this regulation which include procedures how to be approved as DOA for you to be able to design aircraft aeronautical products. Remember now drone is considered aircraft, so this is this. So how to be approved as a design organization? You must be a company, a Sendian Berhad registered with Registrar of Company. Then the company should have the post holders, and the post holders will be obviously the chief of the organization, the head of the company with the chief executive, or could be GM or MD, whoever who are the head of the company. And there will be under him is head of design organization, and then there will be three group of people, which is airworthiness and independent monitoring. So you will have to have chief of airworthiness and chief of independent monitoring, and the guy who are doing compliance, showing compliance, verify compliance to the airworthiness requirement will be compliant verifications. So chief executive, head of design, chief of airworthiness, and chief of independent monitoring are post holders. They are the key person in the organizations. And for the CEO must have the power of finance and must have the power to provide resources for you to be approved as a DOA, as well as to maintain the approval as a DOA. And this chief executive may not be a technical person. He could be financial, legal, whoever. But the most important thing about him, he must be able to provide all the resources required to be approved as DOA and to maintain the approval as a DOA. Next under him is head of design organization. This is a person is technical competent. The person who has experience in interpreting the airworthiness requirement, experience and have verify compliant to the airworthiness requirement, as well as the person who are conversant with the design assurance system of the organization or quality management system of the company. So he has both. He's also a person responsible to ensure all the works related to the design will be according to your company procedures, as well as he are the one ensuring all the compliance shown verified against the airworthiness requirement of the drone that you ask for the approval, apply for the approval. Chief of airworthiness is the person who are conversant on the airworthiness requirement. He's focused and try to understand, he focused on understanding, try to get as much understanding on the airworthiness of the requirement, the airworthiness requirement of the product, as well as able to understand how to show compliance, and also how to do all the necessary analysis of the airworthiness requirement. So he also the one responsible to ensure in-service problem of the drone that you has been certified has been addressed properly. So the organization must have a system that's requirement under Part 21 Subpart A, CM Part 21 Subpart A, which organization required to provide system to record, provide the system to ensure all in-service problems are reported, to provide a system to collect, to register all in-service problem, system to study the in-service problem, system to mitigate in-service problem, and also to communicate with the user, customer, as well with authority on in-service mitigation of the in-service problem. In other words, for us, familiar innovation, these are a group of people required to provide the service bulletin or service letters for the products. Chief of Independent Monitoring is a person more or less like a QA, but it's not a QA, because in the design assurance in the design organization, there is no QA. We have design assurance system. However, he's the person who are required to develop the design organization manual, to maintain the design organization manual, and to ensure everything is done according to design organization manual. So he's the chief of independent monitoring. He could not be a technical person, but he are the person conversant with the quality management system. Compliance verification engineer, this is a approach sanitary or approach sanitaries. This person, technical person, he are responsible to provide, to show and verify compliance to the airworthiness requirement. He's the person doing the test, doing the analysis, doing the flight test, and digest all the flight test data and presented the data, and to ensure all the data that been gathered are able to show compliant to the requirement. For example, for flight tests, you have to show compliant on aircraft performance, aircraft stability, aircraft control, aircraft maneuver. So this very technical person, he should able to understand the requirement, plan for the compliance to the requirement, as well as he able to do the compliance report himself, leading his group to do that. And any other person responsible for making decision, any other person that company like to appoint as making decision on airworthiness requirement or the aircraft, maybe someone who are required to do the study of in-service problem. He not be a CVE, he's not doing design. However, while he's studying the in-service problem, he are making decision on the airworthiness of the aircraft, and those also should be part of the approach sanitaries. So how to be approved? It's not difficult to be approved. You don't have to spend much to be approved as DOA, but you have to have the knowledge. So one of the thing is staff in all technical department are sufficient, numbers and experience. The words there, numbers and experience. So most of the time when I was with industry, as well as with the CA, we have problem on looking at the experience. Finding appropriate people with experience, that is a bit difficult because our industry is small and we do not have that number of projects that we have been working on. So that experience is a problem. So sufficient numbers and experience. So mean the sufficient number, for example, you design code, who has experience in doing a complete flight test on the unmanned aircraft system. It's not flight test, operational flight test, functional flight test. It's flight test, flight performance flight test, stability and control. Those are experience that we're looking for to show compliance to the airworthiness requirement, as an example. Given appropriate authority to be able to discharge the allocated responsibility, mean that your design organization manual should have shown evidence that your manual is able to provide those function of the person in the organization, and also to clearly ensure they are doing the work accordingly. And they should have accommodation, obviously an office, which is not difficult. Facilities and equipment, if you need to do simulation, you may need to do CATIA or Unigraphics or Siemens CAD system or something, you must have that if you need be, or you can just get someone to provide to you in by contract, or you can have that facility. And then adequate enable the staff to achieve airworthiness environmental protection requirement, mean that if you need to do certain tests, if you want to do burn tests, if you want to do structure testing, if you want to do noise tests, those are something you must show that you are able to do it. You have the equipment to do it, or you have contracted someone in the contract are able to support you to do those activity. So those are the condition for you to be approved. And then what are the scope of approval? So the scope of approval will be for DOA is 1, 2, and 3. 1 is type certificate. The new product is under type certificate. 2 is for the STC and modification. 3 is minor mod and minor modification. So we are focused on 1 because this is type certificate. And then there are A, B, and C. A, B, and C is the complexity of the products. If we look at 1A, type certificate of 1A is large aeroplane, large rotorcraft, small rotorcraft, large UAS, and large and turbine engine. If you go for that kind of product, you apply for 1A. If you apply for large unmanned aircraft system like the Predator, for example, or the Anka, it could go into the large UAS. So you have to apply for 1A large UAS. And 1B, type certificate for small aeroplane, very light rotorcraft, small, medium unmanned aircraft system, piston engine, large APU, and gyroplane. So for B, you may apply for like Scan Eagle. You want to apply for the TC for something like Scan Eagle or drone Scan Eagle, the US one. That could be under the small and medium unmanned aircraft system. And for the 1C is on sailplane, very light aeroplane, A-shape, balloon, propeller, and small APU. So you either want to apply either 1A or 1B, and mostly I believe we will go to 1B. That is the most drone that we've been doing now. And after you have the TOA, you are eligible to apply for the type certificate or restricted type certificate. So type certificate is if you say you have a small unmanned aircraft system under the scope, we apply for the type certificate. For you to be able to be issued, CA will issue you with the type certificate of that drone, and then with that type certificate, you're eligible to have flight approval, either certificate of airworthiness. However, currently, CAAM does not issue any COA for non-IQ NX aircraft, so you will get a permit to fly. So that's option. If no COA, then you will get permit to fly. COA is only for IQ for those design requirements in the IQ NX8. Now IQ NX8 has been adopted and adapted become Cat 8. So if you go to Cat 8 and you see part 3 and above, those are design requirements. Those are airworthiness requirements. And you don't see a drone there. You don't see any LSAs there. You see only aeroplane, large aeroplane, small aeroplane, helicopters, engine, propeller. So it means that other than that, there's not eligible for the certificate of airworthiness, standard certificate of airworthiness. Some country, they do issue special airworthiness certificate. So still they do not get a full COA for the non-IQ NX8 aircraft. We call it IQ NX8 aircraft when the aircraft design requirement is according to IQ NX8, or in Malaysia now is Cat 8. And then what you need to do to apply, the first application will be as simple as 3D drawing of the aircraft and preliminary basic data including the proposed operating characteristic and limitation. So first application is very simple, just for us to show to authority what are we going to do, how the product look like, and from there we start the discussion of what would be the certification basis, or in other words, what are the airworthiness requirement that you want to show compliant. Authority will not impose, you are the one that proposing it, and authority will give you the recommendation and suggestion what will be the best for the products. That's why the first important thing, 3D drawing of the aircraft that you're applying for the certification. So what will be the airworthiness code? Airworthiness code that we have CS, LUAS, LURS, LUMRS, and UAS and LSA. That is what we have from EASA at the moment. And if you look at the airworthiness, the code, the requirement by the CAD 4.1, the applicant shall select airworthiness code as specified in the Appendix 1. So Appendix 1 show you CS and FAR. So that is for standard aircraft. However, that we are having drone now. Now JARUS has published CS, LURS, LURS, LURMS, and US and LSA, and most of the drones certified in around the world according to this design airworthiness requirement. Or in Malaysia, we call those airworthiness requirement as Airworthiness Code. This go back to the Malaysian Civil Aviation Regulation, Regulation 25, which state what is the airworthiness code acceptable by Malaysia. And then what you need to do after you have applied for after you agreed with the airworthiness code, you must show compliance, demonstration of compliance, which is 10.1 of the CAT 8201, 8102 or TC, and you have to demonstrate compliance. So what you need to do, every paragraph of the requirement, you have to declare compliant, and also you have to state means of compliance, and also you need to refer back to the reports which are used to justify the compliance. In general, the process of compliance is this is the process. This is what EASA has been doing. Like I said again, certification basis definition, that is the airworthiness code inside here. Mean of compliance, how you show compliance. Compliance demonstration, you should demonstrate the compliance. In compliance verification, after you demonstrate, you write the report, that is and then your compliance been verified. And you have compliance summary and compliance checklist document. So those are the process. This is a detailed process here, which I will explain this if you will go through the training, the proper training or design and certification of drone. We conducted that training, and if we go through the training, we'll go through this box by box, and we also show you how to do it. The time is short here, so I just need to. But however, if someone wanted to ask questions regarding this later, you can ask the questions. So this example, the compliance document, you can see compliance summary. So this example of compliance summary, I have my own project now. I'm designing a helicopter drone, which I believe people have overlooked on this. People start to look at the quad or those multi-rotor, and they forget this is another good drone which has been forgotten, and which this drone mostly still flying in China, in Korea, and Japan. They are doing fertilizing using this drone. They are more accurate. They can go fast. They can carry heavy load. They also use internal combustion engine. So they're very high performance. However, I believe has not been popular in Malaysia because helicopter design itself is complex, and not many people understand how the helicopter works. And most our drone which grow as a droner, I don't think they have full knowledge on how the helicopter operating. I think that's the reason why. But this is the design requirement. I use LURS, like main rotorcraft system. You can see the top, the left side is where I put in the clause, the paragraph of the requirement, and then the explanation of the requirement, and the next column will be the main and compliant, how to show compliant, and reference document or the report that showing compliant. For example, you look at the flight and in LURS.23 approved operational envelope, the applicant must determine the boundaries of the operational envelope which safe flight under normal emergency condition, and emergency recovery capabilities will be demonstrated. So my main compliant will be analysis, then will be test. So that is my main compliant. And then for analysis, I will make reference to the analysis report of analysis, and for the test, I will refer to the flight test report. So that is how to fill up this box. So this example, that is what the TC has been issued, and the FAA has issued as little as the Scan Eagle. I think Scan Eagle is only 8 pounds or something like that. Then it has been issued a TC. You can see here, you can see the type certificate datasheet. For every TC, there is type certificate datasheet. So we can't see the TC because this is just a world certificate, just a certificate. However, the reference is there. Q00017LA. You can see model Scan Eagle X200 restricted categories aircraft system. So remember, we also 8201 TC and restricted TC. So we have the provision for applying for a restricted TC for the drone. And you can see here for this model, this is a Scan Eagle. This is a Scan Eagle X200 that is with a restricted TC. In the US, there is a restricted certificate of airworthiness. And I just study this and what they did. This drone is used to now why they need the TC, why they need the COV certificate of airworthiness for this drone, because this drone now is flying to inspect a railroad, okay, the train track in the US. So that's why they need a COV, because the train track is in the civil aerospace domain, and they fly over the rail track, they fly over people, they fly over housing, buildings, and vehicles. So they have COV for this. So another one is a model Puma, Puma AE, also restricted category with also restricted TC, restricted TC and restricted certificate, special certificate of airworthiness. So that is example of certified drone with a type certificate, and hopefully we will have Malaysian company with this kind of certificate as well. Then why is this important? Because there are many cases of drone, sorry, the spelling was wrong. Drone collisions, not collisions. There are many cases of drone collision with aircraft around the world. There are also fatalities. I've studied aviation safety network. There are more than 20 cases of drone collision with the aircraft, and there are one accident caused fatality. People died when the drone collided into the aircraft. Okay, so that is about